Lesson 3, solving rate problems. So first on the side, I want you to make a note that when you convert minutes to hours, you can either take the number of minutes and divide it by 60, or you can multiply by 60 minutes over 1 hour to your ratio. And when you simplify a fraction, if you have to do that at any point, you take your numerator, push the A, B, C button on your calculator, and then type in your denominator. So, for example 1, describe a situation that could represent this graph. Compare the rates shown and discuss why the rates may have changed. Find the unit rate, kilometers per hour for each section. So we're going to label each point on the graph. So we have A, B, C, D, that doesn't look like a D, and E. So we want to find the section AB. So we're going to take the point, so on the graph it's at the point 0, 0. And we always put our X first, then our Y. And the point B. And it is at 30, 2. Right here. To find the rise, it's equal to y2 minus y1. So with our numbers, this is your x1, this is your y1. This is your x2, this is your y2. Keep them the same. So y2 is equal to 2, y1 is equal to 0. Run is equal to x2 minus x1. Our x2 is 30 and our x1 is 0. So that means that our slope is 2 kilometers in 30 minutes. Now we want to convert this in kilometers per hour. So we're going to multiply by 60 minutes in 1 hour. And what that does is it crosses out these minutes, they cancel each other out, and we'll be left with kilometers per hour. And when you multiply fractions, you multiply the numerator and you multiply the denominator. So 2 times 60 is 120, and 30 times 1 is 30. So we have 120 kilometers in 30 hours. And we want to find it as a unit rate. So you take the top, divide it by the bottom, and you should get 4 kilometers per hour. So from AB, it's 4 kilometers per hour. Make sure you write small because there's not a whole lot of room to write in here. For line BC, it's a flat line, so it has a slope of 0, and that means you're not going anywhere. So you're going 0 kilometers per hour, and you do that for 10 minutes. For CD, point C is at 40, 2, and D is at 60, 5. So it's going to be rise over run, which equals y2 minus y1 over x2 minus x1. So this is our x1 and our y1. This is our x2 and our y2. So our y2 is 5, and our y1 is 2, so 5 minus 2, and x's is 60 minus 40. So we're left with 3 kilometers per 20 minutes. Now we want to find it in kilometers per hour, so we're going to multiply by 60 minutes over 1 hour. This is going to cancel, and we're going to be left with 180 kilometers over 20 hours, and we want to find it as a unit rate, so 180 divided by 20 is 9 kilometers per hour. So far we have 4 kilometers per hour, and we have 0, and then we have 9. Now we're going to do D to E. So we already know point D is 60 and 5. Point E is 70 and 0. So now we're going backwards. So x1, y1, x2, y2. Rise over run is equal to y2 minus y1 over x2 minus x1, which is equal to, our y2 is 0, our y1 is 5. So 0 minus 5, and our y2 is 70 minus 60. So when we subtract this together, we get negative 5 kilometers over 60 minutes. I mean 10 minutes, not 60. I just saw 60. 70 minus 60 is a 10. Now, the reason why we have a negative number here is because it's distance. This is calculating the distance away from something. So while we're driving here, up to this point, you're driving away from your starting point. And then from D, you're going back to the original point. So it's a negative. So we want to convert this in kilometers per hour, so we'd multiply it by 60 minutes over 1 hour. Minutes cancel, and we're left with negative 300 kilometers over 10 hours. And if you find this as a unit rate, I don't even know where to write this. 1 second. So negative 300 divided by 10 is equal to negative 30 kilometers per hour. So we need to describe this graph and what it means. So from point AB, you're only going 4 kilometers per hour, so you're probably walking. So you're walking a distance, and you're walking for 30 minutes. Then from B to C, you take a break. You stop. You're not going anywhere. And you wait 10 minutes. Then from C to D, you realize probably shouldn't have took the break. Now you have to run for a bit. So you get there on time. And then once you get to D, and you're going back to E, you realize you have to get home quick, so you drive back home. So the speeds are going to affect how you describe each section of the graph. So if you're going slower, you're walking. A little bit faster, you're probably running. And if you're driving a car speed, then you're in some kind of vehicle, maybe a bike or a car. So you could make that into any kind of story you want if it matches this to some extent. The gas tank of a new car has a capacity of 55 liters. The owner's manual claims the fuel efficiency is 7.6 liters per 100 kilometers on the highway. You are on a trip and set the trip meter to 0 kilometers and start with a full tank. Each time you stop, you record the distance and the amount you purchased. So you want your fuel efficiency to be a lower number. So the lower it is, the better the car you have, because you want to use less gas. So here's our chart. So on the first trip you drove 645 kilometers. So that's your distance of the first leg. And you used 48 liters. On the second leg, altogether now you've drove 1,037. But we don't want to count the 645. So we're going to take 1,037 minus 645, and you should get 392. And for the last leg, we're going to take 1442 minus 1037, and you should get 405. So now we have our distances and the amount of gas we used. So we're going to find the fuel efficiency for each. So for the first one, we want to find it per 100 kilometers so we can compare it to the owner's manual. So we use 48 liters per 645 kilometers. And because our per is the kilometers, it goes on the bottom. And we want to find it for 100 kilometers. So how much does it take to drive an hour, basically? So we're going to put an X on the top. So now we're going to cross multiply and divide. So 100 times 48 divided by 645 equals X. And you should get 7.44 liters, and we know that that's per 100 kilometers. For the second one, we used 32.1 liters, and we went 392 kilometers. We want to find it for 100 kilometers. Cross multiply 100 times 32.1 divided by 392 kilometers. And solve for X, and we should get 8.19 liters per 100 kilometers. And for the last leg, we use 39.8 liters in 405 kilometers. We want to find it for 100 kilometers. Cross multiply 100 times 39.8 divided by 405, and we get X. And when you type that in, you should get 9.83 liters per 100 kilometers. So we want to decide which one has the best fuel efficiency. So our first one has the best fuel efficiency. If you want to write it in the second gap, so part B, that's the best place to write it. And we also know B asks us which one matches the owner's manual. So only this one is lower than the owner's manual, and these ones are quite higher than the manual. So for leg 2 and leg 3, his car didn't do so well, but for leg 1, he did all right.